Okay, hello everyone. We are here for part 2 of 4, if I
Yes.
understand correctly,
Yeah.
right? Of how to become a searcher with API 3. So if you
Yes.
guys missed it, we had a whole workshop, 2 weeks ago? I'm gonna post the chat. Um, okay, this is like a mumbo. Whoops, I posted in the private chat. Haha.
I'll know it. Okay. Thanks for the alpha.
Yes. Okay, cool. So, I mean, I guess it's in the description of the video, but if you want to
Yeah.
type out 1_Q, you can find part 1 there. Learning about just like the basics of getting price feeds and using adapters. But today we're leveling up to level 2.
Yeah.
Um, Billy, I guess before we start, in case someone's starting from part 2, I'll let you introduce yourself and then we can dive into the Oracle fast lane.
There we
Whatever
go.
that means. I've never heard of that.
You will
So,
know in an hour.
yeah, yeah,
There
yeah,
you
for
go.
sure.
Yes. So yeah, for those that don't know me, Billy or Billy Jitsu on the socials. On there, I do dev relations for API 3. I also do integrations. And for those that know me on the side, I am a huge DGen and DeFi user. Like DeFi is the main reason why I even learned how to code. Curve Finance was the one. So like that's literally I didn't know how to code beforehand and say, hey, this is cool. So I learned it. That's long story short on there. We have a lot of crunch for time because there's a lot of concepts to stuff in the hour. We'll probably go over a few minutes, but I'm going to go ahead and get this started. Let me go ahead and share my screen. Ask tons of questions. Stop me. I can chew gum and answer questions at the same time. Just stop me if it gets too complicated. Let me hide this. We're going to kind of fast forward on our intros, but can you share my screen on the back end, Emily?
Yes.
Okay. Oh, and then let me
Did it work?
get this link. Yeah, it's loaded. I'm gonna go ahead and get all these links here for all the things for you to share so you can reference them. I'm gonna send it on the private chat because I can't do it to the main chat. And that way we can get this going. But don't pay attention to those links unless you want to follow along later. But let's just talk about it. API 3, for those that don't know, we're a first party oracles. We do price feeds. Cool. All right. For those that want to follow up on my shenanigans or interesting takes, you can follow me on the socials. This is the X Twitter profile, my most active social media on there. So for those that are catching them on the second workshop, last time we did the first workshop, which is the fundamentals of API 3, getting started on Remix. You can just mess around with some smart contract, basically learning how to use a price feed. You can do it like in about 7 minutes, get a price feed in a smart contract, mess around with it with testnet, super easy to use. Then you also learn how to use adapters. So like if your code repo was built with another Oracle and you want to deploy on Scroll and there's a certain asset you can't use, no problem. You can learn how to use an adapter and then use API 3 feeds. Why would you want to use API 3 feeds to begin with? Well, this is going to be the best thing. Second workshop, which is Oracle extractable value. Like, what does that even mean? We're going to understand how push and pull oracles work. Introduction to the OEV network. We're going to learn how to update a price feed on mainnet. We're going to bid on the OEV network and we're going to win the bid and we're going to update the price oracle. Third workshop, once we understand that, is we're actually going to deploy a borrow lending dApp. We forked Aave and we built a CLI tool that lets you deploy the whole thing all in a single sequence on there. Super cool. You're going to learn how to liquidate positions using the OAV network. So you're going to monitor health factors. You're going to learn how borrow lending works. You're going to understand how liquidations work, why they work, how to discover profits, and then basically bid on the OAV network, update the price, liquidate, right? We're building you up little by little to become a searcher. Fourth workshop. Okay, now that you understand how to liquidate, maybe you don't have $1 million to pay back that $1 million loan. Well, that's where flash loans come in. Understand how to borrow that money and then pay back the loan, do a swap, pay back, and then keep the profits all in the single block. And that's how you use the OEV network and how to get that allow list. And we're going to discuss that a little bit later, but discovering the full potential of OEV on this space. So the total focus for today is price feed using the OEV network. So workshop breakdowns for today is like, where is the value going, right? Oracle extractable value. What does that mean? How is value being lost on these borrow lending dApps? What is the flow of the current meta? And then how to update a price feed with OEV. So you're going to create a bid. We're auctioning off the Oracle structure. and then we're actually going to execute that, and we're going to update the price with a multi-call. And I know I say multi-call and people may not know what it is. We're going to cover that really quick too. So what is Oracle extractable value? How do oracles work? So prices change on assets every second on the second. Like if you go onto Coinbase, Binance, whatever your centralized exchange of choice, you can watch that ticker go up and down for every second. It goes up a penny, goes up a dollar. It's constantly changing, right? But if we do that on chain, API 3 would be out of business within 2 weeks because every transaction costs gas, right? So there's a limitation to that. Like if we were to do that every minute on the minute or every second on the second, we'd be basically throwing, 2 cents, 3 cents every second of every change. So consensus overall for push oracles is that we update at certain thresholds that matter, right? So if the price changes 1% or 0.5% or 0.25%, we are willing to not to negate that value. If something goes up 50 cents, does it really matter for certain objects? For borrow lendings, it doesn't. 1% has been pretty good overall, and that's pretty much the standard that we've been using for years. Oracle extractable value allows anybody, that means me and you too, Emily, that you can place a bid to update the price feed at any given time. We don't have to wait for that 1% deviation. So what's the extractable value part? Let me give you the scenario, right? So there's a liquidable position on Aave. ETH, let's say ETH is valued at 2012, right? Like right now. I could be right. I did this in the future and we're like, the market's pretty close. We're almost there. So for simplicity, let's say ETH is worth $2,000 right now, and the Oracle has a 1% deviation price update, meaning at 1%, it'll change price. So the only time the Oracle will update on chain is if the ETH value is $2,020 going up or 1980 going down. Other than that, it will always be $2,000 on chain, right? So we're looking on CoinGecko or wherever you want to look, and your ETH is on a climb. 2000, 2005, 2012, 2019, right? So the price of ETH is at 2019, but we still cannot liquidate because it does not reflect the value on chain, right? So even though I can liquidate this 2012, in theory, I can't do it because it hasn't updated on chain until ETH gets to 2020. If it never gets there, that person is safe, and we never had that opportunity. So at the point ETH hits 2020, the price updates, it becomes an MEV battle, right? Of bribery payments to the validators, right? Who's going to have that first transaction first? How much ETH am I willing to pay to put this like on a flash bot or something in order for my transaction to go through, and then I get that profit, right? So the most possible profit goes to the validator, right? I'm willing to put whatever, 10 ETH or whatever, to do this liquidation that might generate me 11 ETH. So I get to keep 1 ETH, right? But 10 ETH went to the validator, right? The DApp doesn't get anything. They have to pay that 5% reward or 10% reward in order to stay healthy. So the one that's really winning is the validator, right? So just to like visually see this, right? We are ETH at $2,000 on chain. We have our liquidation event, and then the current value of ETH is 2019. So nothing happens until we hit this mark here. Just to give you a visualization of like how push oracles update on chain. It updates in increments of 220. If it hits 220, what's 1%? 220 is like what, 20 and a couple cents. So then it'll update at like 2040.01 or something within that range on there. So MEV flow, just to give you a visual on that as well, we have the searcher, right? It sees the opportunity. It pays a large fee to be first to the validator. So let's say it's 1 ETH, right? That validator keeps the gas fee and puts my transaction first to then liquidate this borrow lending platform. I get the liquidation bonus and minus the 1 ETH investment, and I keep the profit. So just to show, validator takes 1 ETH profit, searcher gets the liquidation amount bonus minus 1 ETH, and the borrow lending DApp gets nothing out of the transaction, and they lose 5% TVL based on the rewards they had to give out on there. So boohoo for the borrow lending DApp, right?
Boo-hoo. Sorry, Ave.
Because everybody measures things on TVL, right? Your value
Mhm.
is how much you have secured. Oh, it has billions of dollars. It must be good, right? But if you're leaking value over time, you're leaking what theoretically makes you good. So
Mm.
how does OEV aim to help with this issue, right? So searchers, they can bid to update a price feed through the OEV network, right? If they win the bid, they receive a signature that allows them to update the price feed that they won. So the signature is bolts with a liquidation transaction using a multi-call contract in order to do multiple transactions on the same call. The price feed is updated and the liquidation is performed. So like the value, what happens is instead of bribing a validator, you are now sending that value to back to the DApp and a split between API 3 and the DApp. So the DApp gets 80% of that value back to them. So here's a flow. This was much more detailed. Don't get nervous. I'm gonna actually like pull a pen out so I can give you the flow of that just to show you. All right, so we're starting here as a searcher, right? And so we're gonna go ahead and bid our price feed. Like say we want to update ETH, right? So we're going to the OEV network and saying, hey, we want to bid to update ETH on Scroll Network, right? The catch is you have to put a little bit of ETH on the network in order to stake. So like you have to put a little skin in the game to play, because if you just bid without having any penalties, bunch of people could bid and then not update the price feed, and then it blocks somebody else. So you have to put a little skin in the game on there. So it's only 10% of what you're willing to bid. So if I'm willing to bid 1 ETH, I only have to have 0.1 ETH on the OEV network. We want to keep your liquidity on the chain that you're doing bids on. So it's only 10% of what it is. So I'm setting the bid and I'm listening. Did I win the bid? And magically we won that bid. So we're just like, okay, I want to update ETH to 2012. Did I win? Okay, cool. Now I have this signature that comes back to me as the searcher, right? I'm going to go ahead and say, all right, I want to update the price feed. So I'm going to send this transaction to the sequencer on Scroll. And then I also have to make sure that whatever I bid, I have to send that bid over to the API 3 server, right? So if I bid 1 ETH, I bid my 0.1 ETH on the OEV network, I have to send that 1 ETH in order to actually update the price oracle. That was what I was willing to bid. That's what I have to send. Once I hit my liquidation transaction, the token price feed updates. So now it's updated to 2012, and now I can run that liquidation on the same block. What's the overall process, right? The searcher profits, minus the bid amount, whatever they do the 1 ETH. API 3 server holds the bid amount on there, so they're holding the 1 ETH. And then the borrow lending DApp loses the 5% TVL, but the borrow lending DApp gets their claim of what was bid on the API 3 server. That's why we have the slogan of like oracles that pay you. So with every other oracle that you use, you lose 5%. But with this on a layer 2, if someone's willing to do a bid to update the oracle, you get about up to like 80 to 90% of that value back, whatever people were willing to basically do that for you. So let me go ahead and trash that. Make sense, or are we still kind of iffy on that?
Whoops, I muted. Said
Oh,
it makes sense. Mine,
okay.
I'm more just like, is this guaranteed? Can I make money for sure?
Yeah, well, actually, I mean, based on the last transactions that we've done on bots, we had a 99% success ratio on the market volatility. So anybody using the OEV network and the bots that used OEV, they got 99% of all the liquidations that happened on that last volatility market, which was super awesome. So using that same example, right, we are going up and down. ETH is going up in value. We see that liquidation value that we wanted 2012. So instead of waiting for it to go all the way to 2020 to update, I'm doing that bid value. Say, hey, if it hits 2012, I want to win the right to update the oracle. And so as soon as that value hits 2012, that's when I get my signature bid. I do my update of price oracle and then run the liquidation. So I don't have to wait for the entire deviation. I get to win that battle.
Mm.
Let me clear that. Let me clear that and go. So what's needed to build a searcher bot, right? It's not about in theories. Let's actually build it. You can do almost any scripting language that has an ETH library. So Ethers.js, VM, Python, Rust, anything that has a connection to the Ethereum network library, you can use it. Our example is going to use Ethers.js and JavaScript, like the most simplest version to get started. You need to deploy your own multi-call contract, and that is how you're going to do your liquidation contract calls. So everything that you do through liquidations will happen through a contract. Kind of fast forwarding over, most people will use a contract to do liquidations because you do flash loans, and you cannot do that from an EOA. You have to use smart contracts in order to do it. So if you look at most liquidators today, they're all doing it from smart contract calls because it has a lot of extra features that you can do. You can bulk transactions. You can do a lot of different things that you can't do on an EOA. So you want to get in that habit of deploying a multi-call contract that you own, that you can control and modify for your needs. In this repo, you don't have to modify anything on the contract. We built it for you. It's all ready to deploy. You don't have to modify anything. You can if you want to for your needs, but you don't have to. So let's go through the liquidation flow of just pretty much how it all works, right? So you are the searcher. This is the OEV network, color coded right here. So you as a searcher, you find an opportunity, right? You find a health factor, you calculate the price of liquidation. Oh, this person's going to get liquidated at 2012 if they don't change the position. So you place your bid on the auction house contract on the OEV network, saying, hey, in Scroll Network, I want ETH 2012. When it hits it, I'd like to win the right to update that oracle so that I can run that liquidation. You send up a listener to see if you win this auction, right? You could place this bid at 2000, you can place this bid at 1900. Doesn't really matter. You can set a time schedule to see like how long the bid will last. But you receive this winning signature and say, hey, you won the right to do so. You combine your price update with your liquidation transaction. You call it on your multi-call contract, and then you send it price feed updates. Liquidation occurs, profit, right? So pretty straightforward from the searcher to the OEV network. Yeah. Okay.
Yep. I'm like,
Local
oh,
computer
how do
flow.
I do this?
This is what's happening on your local computer flow. And this is the layer 2 network, right? Where we have our multi-call contract. So this is Scroll Network. So on the layer 2 network on Scroll, we have to look at all the addresses that have ever borrowed on the borrow lending platforms that have ever deployed, right? Most popular ones right now are Aave and Compound on Scroll. So from deployment, from that block, whenever it was deployed, to how many people have deposited, to how many people have borrowed, we need to keep track of that. You can use whatever tool you want. Some people use Dune Analytics to get it started, and then some people use other tools in order to get a list of what's available. You got to store those addresses on your local computer. If you don't, you're slow, right? And so now you have to monitor the health factor of all those users, right? So some people are going to have really good health, they're not super degen, and then you have this small list of people that are right at the edge. Like if ETH drops or increases, where are my opportunities at? You're going to store all those opportunities on a list, right? Those are your active databases. You can use anything you want on there. So you can use SQL or however you want to house your own databases. You have all your calculations of your liquidation prices. So you have a long list of liquidation prices that you have available for you. Those get sent to the OEV network. You have your liquidation thresholds. If you win any of those, you get the signature back. You combine, again, all those winning details for the auctions with your liquidation transactions, and then it kind of falls into place. You call your multi-call contract, update the proxy feed, you perform the liquidation, profit, right? So that's kind of like a little bit more details of what's happening on your local computer in order to be a searcher. All the magic happens on the OEV network, right? So full flow, right, with everything that goes all together, putting it all together here. Again, we're gathering our addresses right here on the Scroll network. We have them all stored in a local database. We're monitoring health factors across all these different assets. We're storing our opportunities, and we have all our liquidation prices calculated already. Here on the OEV network, we've already bridged our assets to the OEV network. So now we're just going to set up our bid conditions on here and basically all our liquidation prices. We place our bids on the auction house contract, which is on the OEV network, and we're listening. Did we win? Did we lose? You set up your limitations of how long you want to have these bids for. We magically win the auction, and we receive all our signatures that we get for each one of our networks or each one of our price feeds. And then we bulk our winning details with our liquidation transactions, and then call our multi-call contract, update our proxy feed, perform the liquidation. And then the final step right here is report that we updated the oracle. Again, remember, we want to make sure that everybody pays fair. We don't want people setting up bids and then not updating the oracle, because then that ruins an opportunity for somebody else. So if you don't let the OEV network that you did perform the oracle update, you get slashed on your bid on there. So it puts a little skin in the game. If you don't behave properly, you will get slashed. But this is the overall flow of a searcher. Ultimately, they're looking for opportunities. They see opportunity prices, and in most cases you kind of skip this and you have this MEV battle, but here you're just doing like bids on here, so you're taking your time. It's kind of why I call it MEV on training wheels, because you're not battling for block position. You're just bidding to win an auction, and if you win the auction, you have the signature that has it set to your wallet address, so it doesn't matter where you are in the block, right? Because sequencers work differently on all different layer twos. Some are first in, first out, some can reorder, but all theoretically, none of them you can bribe the actual sequencer. So it becomes a problem of like, well, how do I get opportunity on these liquidations, right? You see searchers that will buy servers next to the sequencer server, so they like 2 milliseconds faster, right? And so now you don't have to worry about that. If you win the signature, it doesn't matter where you are on the block, you will win that liquidation. And I don't know why Discord is constantly pop up. I'm popular today, I guess, right? So the details, right? So on the OEV network, again, you need to deposit 10% of what you're actually going to bid in the auction, right? So if you're bidding 1 ETH, you need to have point 1 ETH in the auction house contract ready to go. You don't pay a fee on the OEV network. Like you're not paying the 1 ETH on the OEV network. You're paying it on the chain that you're updating that price feed on. So if I'm bidding for Scroll, I pay that fee on Scroll. The fee value gets passed to the API 3 server contract and then in the price feed transaction. So if you don't pay the fee that you were willing to bid the update or bid to do the update, then the update won't happen, right? You have to meet all the transactions. So if you bid this, you got to be honorable and pay the fee. Otherwise, it fails and you get slashed, right? The DApp can then withdraw the value to their contract and they can use that value however they see fit, right? So this is what opens up the market for borrow lending dApps, right? When a large entity like Aave or Compound come to your chain, they kind of overshadow most borrow lending dApps, right? Oh, Aave, oh, just use Aave. Oh, just use Compound, right? So what makes you set apart from all the other borrow lending dApps is what ideas you have with this newfound money, right? They generate income by people depositing and people borrowing on there. And if there's not enough volume, then what's the case? So now that you have this newfound value of liquidations that have occurred, now you have ideas that you can do. You could do higher APRs. You can do lower liquidation penalties. You could fund public goods. You can do raffles, whatever. It's money that you were leaking out anyway. So now by using our Oracle, you have a newfound income, right? So you can do something that will set you apart than all the basically forks and borrow lending ideas that are out there.
Can you clarify, were you implying, so like what the suggestion is, like for smaller borrow lending platforms to just, I guess, differentiate themselves by using OEV on their
Mhm.
networks? Okay.
Yeah, I mean, so like, I mean, even if Aave or Compound did it, like it again, you can again make a bigger gap of the the lead you have because let's say they generate $100 million, but then they're leaking out $50 million a year, and then that like 90% of that gets returned to them. So let's just say off the top, 45 million in their
Mhm.
pocket for that year. What would
Yeah.
they do with that $45 million, right? They can improve, they can do all kinds of things, they can have
Yeah.
campaigns, right? So like it's a very, very big thing of losing that, paying that 5-10% leakage to
Mm.
MEV versus what's happening. And then the ability to have theoretically priority on a layer two is something that searchers are looking for, right? Because
Right.
you can't
Yeah.
bribe a sequencer because there's only one. So how do you get advantage? You use OEV, right? So yeah, more details like your bid details on the OEV network is basically the address of the transaction sender for that winning signature. So you're basically telling, hey, my smart contract is the one that's going to do the update. This is how you don't get front run on the sequencer, right? Because everything's in the public mempool. They're seeing that you're updating the Oracle. And if you do that without a multi-call contract, you're going to update the Oracle, and then some other searcher is going to say, hey, thanks for the update, and run the liquidation and front run your liquidation, right? So if that address is not calling the price feed update, it will fail. That way it stops the front running. It's like, that's why I call like MEV on training wheels. So the multi-call contract is what allows you to combine the transactions in a single transaction call, right? You do the price feed update signature first and then the liquidation. If you do the liquidation first before the price feed, it will not work because the price feed has not updated first. So it goes sequential. And then again, if you call it without the multi-call, your next transaction can be front run. So if you send the multi-call and update the price feed, whoever's next in line is going to win that liquidation. So if you don't bulk it, you will lose it. I can guarantee you. So for those that want to see the repo on all the demos, this is basically all the links to all the examples that are available to it. It's all set in sequential order. There's video breakdowns, but let me just kind of show you as we come through here. Let me grab all my links.
I guess
Yeah.
just to interrupt, for those
Yes.
who aren't familiar with multi-call contracts, and you just like give a brief
Oh yeah,
overview.
that's
Yeah.
it's already here. So
Oh, perfect.
multi-call, there's a whole multi-call tutorial right here on this link that has a total breakdown of what multi-call is. The number one thing that I hate, and I'm going to call all developer relations on this, is people assume that certain things, right? And
Yeah.
oh, just point to this one like tutorial that has been like used from like 2017 and say, oh yeah, no problem, right? Oh, multi-call 3 is on every chain. and then you try to look at the information of how to use it, and it's not there, right?
Right. Yeah,
Alright,
yeah,
so I
yeah.
spent more time trying to figure out something, so I created a repo in the ecosystem that shows
Nice.
you how to use multi-call, right? So there's a multi-call tutorial, repo covers it. There's actually a video walkthrough tutorial on there of, like, how to use it and everything, so, like, it takes you to YouTube and basically gives you the breakdown of, like, how all the transactions work. So video breakdown of that basically goes through all the different contracts, why it works, how it works, understanding this, using the tools to break down ABI decoding, Swiss knife. So there's third-party tools that you can use, and it has internal tests too. So you can play with it, run it, do everything you want. So like, yeah, it's kind of like starting you from like zero to nothing. So even if you get nothing out of OEV or you hate OEV, I hate API 3, you'll learn how to use multi-call, which is actually very, very useful for other uses. And that's kind of like leading me to the segue of my multi-call gifs of like why people use this. Even
Mhm.
if you're a front end developer, oh, I don't do smart contracts, I don't want to be a searcher. Multi-call, let me explain what that is in general. So when we have one RPC call, like if you call like an RPC on, let's say, my balance or balance up, right? It is a single call, right? And so if you're using Scrolls RPC and if you're a front end developer that has a wild use effect, you will realize that you get rate limited pretty quickly, right? Because every time you call a smart contract, come back, that's one call, right? So it's 1, 2, 3 calls, right? And then kind of repeats over and over. With multi call, you get to call all the contracts in the same time, and that equals one call, right? So you can basically save on your RPC overhead, and if you're especially paying per call with multi-call. So you can read smart contracts as, I would say, off the top of my head, maybe 40 smart contracts in a single call. And it does do a loop, but it only counts as a single RPC call. So it's a lot of heavy load on the back end, but this is how we take advantage of this through multi-call. So, why would we use this for our needs, right? If you're a searcher and you're looking for opportunities across borrow lending dApps, you need to keep an eye out for all the different lending dApps out there, plus all the positions, right? So let's say you had 100 people, you got looking at Compound, you're looking at Aave, you're looking at all the different borrow lending dApps on Scroll. Well, you're going to run out of RPC calls really quickly, especially if you're focusing on one dApp. So basically, what we do is we create this bulk, and then we look at all, bulk it all together, put in multi-call, call all the contracts on all the positions that we have, and then we bring it back and then we can analyze them. So this is why you would use the multi-call contract. Also, you want to bulk your transactions here. This is what we're going to do. We're the searcher. We combine our transaction of updating the price feed and the liquidation, combine that in our multi-call contract, update the price oracle, do some magic flash loan, and then we actually then execute it on the borrow lending dApp. So this is the ultimate goal of using your multi-call contract. So yeah, that's why you would use multi-call. You can use it to read and save RPC calls, and you can also use it to bulk local transactions into a single call. Some people may do that in smart accounts, right? Like if you can approve and do a swap on a single call, like with smart accounts, well, that's just basically a smart contract that can do multiple transactions. That's what multi-call can do overall. So yes, if you want to learn all about that, that's in all the group of tutorials. Multi-call tutorial has a video breakdown, all that ready to go. So it's there. I came prepped. Boom. All right.
Perfect. Also,
So
wow, what is that animation software? So cool. Or is that
oh,
just
I did After
PowerPoint?
Effects. After Effects.
Oh, okay.
Yeah, I spent a lot of time on that. That whole breakdown is a whole thing. So, in this version of OEV, we have a playground on there. For speed, I'm going to kind of do it myself on there, but usually I have the co-host do it because it's that easy. But right now, for speed, because I know we have a hard cap, I'm going to go ahead and like take us through here. So, we have to bridge ETH to the OEV network, just like how you have to bridge the scroll. You have to have a little bit of ETH in order to play on the OEV network, right? And actually, let me kill this thing in the background. Let me go here and I'll bring up my code. Yeah. Okay. And I've got so many things here. Okay. So I've already bridged it. It takes 10 minutes. So we don't have 10 minutes. So I've already bridged it. So what you want to do is, okay, now we have some ETH on the OEV network. We need to deposit a little bit of ETH in order to actually do some auctions, because just having ETH on there does nothing. We need to deposit it into the auction house. So I'm going to go ahead and just grab some ETH right here, and I'm just going to deposit a very little amount here. It's going to do 1.0001. So like it's just changed. Right now, if you're practicing, this is only available on mainnet because you don't really do liquidations on testnet. No one's putting real money. So there's less of a demand for real-time updates, even though they are on testnet for actual money, because everybody uses different tokens for USDC for different assets. So it's very hard to actually emulate liquidations on a testnet when there's one USDC to rule them all, and there's one USDT, and ETH is actually real. So it's difficult to do this on a test net for real-time purposes. So I'm doing it a minute. So this is real money, but you could do, again, it's like 20 cents. And so you pop in your OEV network, and I'm going to go ahead and confirm that in there and wait for that OEV network transaction to go through. My MetaMask is like super slow. I don't know why, but we are live. So I can now place a bid. And so what am I bidding, right? So I'm bidding that on Scroll Network, I would like to update ETH USD. So let me scroll down here, and you can update any one of these things, but we're just ETH USD is one of them. And I want to bid, I'm just going to grab this really quick for this submit bid because it's like really, really small. I can min bid because there's not a lot of competition. The market's pretty sideways. So like min bid is pretty safe for me to win. So I'm bidding like 0.1 cent on here for this action on ETHUSD. I'm betting that ETH is less than or equal to $3,000. That way I know I'm going to win this bid in the next bid auction, which is happening like every minute on the minute on there. It's updating the price feed. So I know I'm going to win this because whatever ETH value is going to be less than 3,000 unless ETH has changed
Shh, don't
dramatically.
say that. I'm sad.
So I'm going to go ahead and place my bid. And I'm going to confirm it. And so now I have my bid ready to go. So I'm going to listen for that once that goes through. Let me make sure that thing on here. Where's my activity? It's still pending. But here's my bid details, right? I'm on Scroll. I'm bidding on ETHUSD. I bid this amount, and my bid condition is less than 3,000, and I've won. I've been awarded my status, and so my data feed is going to update to the latest value. Right now, it's reading 2428, and it's going to be 2464. So I'm going to go ahead and switch over to Scroll because remember, I need to do this in Scroll. I need to pay out my bid amount, so I'm going to switch over and I'm going to execute my update. So it's going to make sure that I'm paying my 001 ETH, and it's going to do this. So we already have a built-in multi-call. And let me just speed this up just a little bit and confirm that. And so basically it's letting me know that the collateral amount that I have has been locked up. So my bidding amount has been locked up until I prove that I've actually behaved and updated the Oracle. And then once it's been updated, then I'm like, okay, cool, it's been complete. So let me see if it updates. And here we go. 2466. It's been updated, right? I didn't have to wait for the deviation. It's now happened, and I could have run my liquidation. So now that I've done that, I'm going to report my update back on the OEV network saying, hey, I behaved, I updated the Oracle. Whatever I did with that update, it's totally up to me, but I did play fair. So I'm going to report that update and confirm that. And they're going to let me know, hey, my deposit has been reviewed once it completes. And then my 0.0001 ETH that I basically deposit is now safe, right? I can use it again over and over again for what another bid. So I don't have to keep bringing ETH into like OEV network. I just have to do whatever I'm willing to bid. And there we go. I've been refunded. Everything looks good. And now I won, right? So ta-da, I did my liquidation on there. So that's pretty much the flow of OEV network, right? We make sure that we have a little bit of ETH on there. We deposit on there. We place our bid or whatever we are looking to bid update. If we win, we execute the update and then we report the update. So let's get into the code if it all makes sense. Yeah.
Yeah, I think
Yeah.
so.
Okay. All right. Yeah. If you have any questions, stop me. So breaking down the interfaces here, we have two different things in the contract with a couple interfaces and vendor. The goal of this is to make it very simple. We don't have to understand, like, you don't have to be a mechanic to drive. I just want you to drive, right? So all you really need to know is understanding the multi-call, which is in that repo example. And the reason we have you deploy your own multi-call versus using like multi-call 3 that is usually deployed on a chain is because the value that you liquidate is going to go back to your smart contract, which is here. And if it's not limited to only owner, someone can just, swipe it from your smart contract while you're doing your transaction, right? So you have your ownable function here is to say this is your multi-call contract. So no, once you do the liquidations and you have it, now you can withdraw that value and do whatever you want with it on there. But don't use a public multi-call because you will get front run if you do all the hard work, pay the bid, do the liquidation, pay back the loan, and then at the end of the day, someone swipes your smart contract. Sucks. So use that. But ultimately, what it does is just, basically loops through all your arrays of targets. Targets are the addresses. Data is what the batch call is. And the value is how much ETH you got to send with that value on there ultimately. And I'll explain it in a little bit more detail. But it loops through all your transactions and basically runs it and sees if it's a success or not a success, and then returns all the data for you. Nothing too difficult. Well, look at the multi-call breakdown and it'll make more sense for you on there. But basically all happens on the same transaction. If it fits in the block, it'll take the block. The OEV auction house is just an import. What we want is you to not worry about the auction house. You can bid and you can draw, and that's pretty much all you really need to do. If you want to see all the stuff that's happening in there, it's in the link. Let me grab that link. It has all the details of all the interface here. Let me grab that here. And you can, break it down step by step of all the information that's on here. You can select collateral basis points and all that, but basically what you have to deposit, if you want to withdraw, if you want to place a bid, expedite a bid, or, listen for events. It has all the details in there, but you don't want to get caught up in that. We just want you to bid, right? Like when you do something on OpenSea, you just list and bid. You don't have to understand how it all works. Just know that it works, right? So we just have a simple import for you to bring in, and all that does is bring in the ABI for you to call. Right. So those are the two contracts that we have. And then we just have interfaces for that for you to call on your scripts. So the main thing right here is the scripts. Right. And then just for those that are looking at the hard hat configuration, you're like, well, where's all the configurations? Where's all the networks and everything? We have a source for all the chains that we support. If you went to the marketplace and saw all those chains, you can see that we have a whole bunch of chains right now, currently 39 different chains. So like, how do you manage all that? Well, we do it for you. So there is a link straight to the deployment addresses that links into the GitHub that you can see all the addresses based on the chain ID. So all you have to do is type in the chain ID, and then it'll automatically go to the proxy contracts or the API 3 server on there. It's ready to go. So if there's any changes, you don't have to change your code. It's always happening on the addresses here. So you don't have to like look up which contract is, API 3 server on scroll, what is a proxy address of this. It's all here ready to go. Again, that's also a link in the list as well in the API 3 deployed contract addresses. So that way you don't have to, fumble with anything on here. You just the API management, and then you're ready to rock. It handles all 39 networks for you, ready to go. And then one other thing in the package JSON, you can see that we've created some scripts for you to make it really, really simple. These are the 3 scripts that you need to do for OEV, which is basically deploy multi-call, which is this script, deposit collateral, and submit and bid update on here. Just like we did on the wizard, step by step, you pretty much go down the list on there. So we just made it really simple where you can just do yarn and then do what the function calls. So I'm going to go ahead and get rid of this deployment, and I'll explain what that is in general, but I'm going to remove that. And we are kind of starting fresh. I've already yarn updated and downloaded all the repos. And let's start with deploy multi-call. So whatever chain you need to have a multi-call smart contract on that chain. So if I'm just starting out on Scroll, I need to deploy it on Scroll, right? And so if you look at our .env example, you can see that it takes a mnemonic. Why do we use a mnemonic? Because I like to be able to adjust different wallets on the fly. Private key is only one wallet, one source. Let me make that bigger, actually. So when I want to create, maybe generate two positions with two wallets, mnemonic is the way to do it on a script, right? So like I can just keep pulling wallets and generating wallets on the fly with a mnemonic. With the private key, then I have to add like 10 private keys and then do it. So mnemonic is just the preferred way for me to run scripts to create positions and borrow lendings and whatnot. If I do it all from the same wallet, it's kind of like I'm doing all this private key handling. So I just do mnemonic, right? And then the OAV network, there's only one RPC, so that's pretty much it. And then your target network RPC for this one, I'm just using scroll DRPC. If the RPC gets too heavy, like the regular minus D one, I just use the D. So unless you have your own private one on there, so that's it, pretty much ready to go. So all we want to do is deploy this multi-call. All this is a deployment script. The only added feature is that it saves your deployment into a local JSON file. So we reference that later. And you're going to see when I deploy it, that there'll be a little thing that shows up here. So let's go ahead and do that. Yarn deploy, oops, multi-call. And I'm going to make this a little bit smaller because, like, there we go. I'm a little too geriatric. I couldn't see the top of my text here. So I'm going to go ahead and deploy it. So all it's going to do is to deploy our multi-call contract on scroll. And there we go. And you'll see that I have a deployed contract right here. It's 9920. And you see this deployments.json. That's our OEV searcher multi-call contract on scroll network. I'm doing this on mainnet right now because I'm actually going to do a live update on here. And so this is our reference address. So instead of typing that into our submit and update, it's just going to refer to this deployment on here. So it's just saved for you. So you don't have to like update any variables. That's all that does. Okay. So now that we have our multi-call contract, we want to deploy some, deposit some collateral that we've already bridged on the OEV network. And so all this is going to do is basically grab our OEV network RPC URL, grab our mnemonic, and basically create our smart contract object for the auction house. We're going to deposit a very, very small amount, like 0.001 ETH. You saw me do that through the wizard. This is just the script version. I'm just going to deposit that so then we can start doing bids. So I'm going to go ahead and do yarn deposit collateral, and then pop that in there. Wait for that deposit to happen. And there we go. I have deposited 0.00001 ETH into the OEV auction house. This is my transaction hash. I'm now ready to bid and update. All right. This is the meat and potatoes of the entire thing, right? We want to submit bids. We want to do updates. We want to do multi-call, the whole spiel. So let's go ahead and like minimize this because I know it looks scary in the very, very beginning. But if we look at it, we're going to look at two things. We're going to place our bid. We're going to perform the OEV update, and then we're going to report the fulfillment, right? That's pretty much our three main things. If we looked at the wizard, remember, place bid, update the oracle, report that we did it, right? And so let's break down each part of the sections. It looks like there's so many imports, but really it's just ethers on here. The team decided to use individual ones to show you the exact ones. A lot of people like using ethers dot, right? So then ethers.wallet, ethers.json, RPC provider. They just chose to do it each one by one on here. API 3 contracts is that same contract list of all the deployed network calls, right? So all the addresses. So you don't have to like manually type in addresses for API 3 contracts. You just import this in and it has the entire list. So you reference them by chain ID. Our deployments.json is our multi-call, right? That's that multi-call that we had here on our deployments. We're going to import that. So whatever we deploy, if we deploy a new multi-call, it gets overwritten. We don't have to update it here as well. And then the .env for our mnemonic and RPC calls. So, okay. So let's break down what we're looking at here. This is a function right here that's called bid topic. The OEV auction house inversion that we have right now takes a bytecode on here. And so before it was set to have like what's the chain ID and what's the proxy oracle, like ETHUSD, what's the price feed oracle for that, and then it would generate the return. With this version, it requires the same number. So this is just a random like static return for this auction house V1. So you don't really have to know the details on that, but it's basically the bytecode that is required for your bid topic on there. So part of your bid that we were doing on the back end didn't show you that because it was just all on the front end, but just know that this is required on here. On V2, there may be a thing where it grabs the proxy address and the chain ID and it might return a different bid topic, but for right now it's just static. So don't get too caught up on the bytes on that here. Bid details. This is a function that's going to convert all our information and then encode it for us. Because remember, when we do multi-call, we need to do things encoded instead of having it like just raw data. It needs to be encoded to fit in a multi-call smart contract. So what are we doing? We're getting the proxy address, which is the price feed address, which is ETH/USD. What are our conditions? Is it going to be, less than or greater than? What condition value? Is it going to be less than something? Is it going to be greater than something? We calculate our liquidation prices. So I want it less than 2012 or anything like that as well. And then who is doing the update address on Scroll Network, right? That's going to be our multi-call contract. So this function, basically, when we pass the details, it's going to encode all this data for us. This extra step right here, Hexafly randomizes the bid, right? So like if two people do the same bid at the same time, this kind of separates the auction so you can identify your auction on there based on the bid ID. Make sense so far?
Yeah, I think so. My
Okay.
brain is working at like 100% right now, but
Perfect. There we go. We're about to use 10% of the brain right here. All right. So here's where we get into the details of place bid, right? So this is like, okay, where is the proxy address? What is the price feed that we want to update, right? And so where do I get this from? This is the default USD and Scroll mainnet. So let's go over to the marketplace and decide what price feed we want to update, right? So I'm going to go to Scroll, and again, I'm doing this on mainnet. Scroll. I'm going to look at the active price feeds, and I see ETH/USD, and I see the value, and I want to integrate it. Right here is the proxy address. So this is the address that I want to update right here. I want to do this ETH/USD price feed update. I'm going to paste it down. You're going to see it's the exact same thing, right? Because I already did it on here. So that is the price feed. If I wanted to do wrap BTC, I would go back, go over here, look for it. If it's live, it'll have a green dot, and then integrate that, grab that wrap BTC price, and then grab that. What is the chain ID? Scroll mainnet 534 352. We know that. How much is our bid amount? I'm doing that same bid amount, 0.00001. Very small, right? We're not competing for liquidation, so I can get away with a low bid amount. Once there's more competition, your bid amount's going to have to be higher, right? Like MEV battles, like whoever wants that liquidation, more people that adopt OEV, you're going to have to bid a little bit higher. What is my bid condition? Less than or equal to or greater than equal to. For right now, I'm going to say, the bid price is less than $3,000. So I know I'm going to win that bid, right? And then now we're just building the smart contract object, right? We're getting the RPC provider, which is our, that drpc scroll, whichever it was. And then the ABI, which we downloaded from our contract, and then basically building this out. The contract address, again, we're using chain 4913. That is the chain ID for the OEV network, and it's referencing those auction house contracts that we had deployed for the API 3 network. Remember this import right here, these contracts. So that way you don't have to keep remembering the contract addresses. Just refer to them by the chain ID, and they will always be the most accurate one at every time. Right. And so now that we have all these details on here, we're going to call these functions like get the bid topic. Remember that bid topic was that static number. So we're going to get that static number. And then now that we have our bid details, let's run that function and encode all these details because it doesn't take this data directly, has to be encoded. So we're going to pass in the proxy address, the bid conditions, the bid price, who is going to be our updater. Remember, that's our multi-call address. And then we're going to randomize this right here. So it's going to pass through, go through this function, and we're going to get back an encoded byte code on here. So like it's just basically calling this function and encoding all that data. Now we're ready to place our bid in the auction house. Remember, we built our auction house on the OEV network. So we're going to place our bid, and that's going to take in the bid topic. It's going to take in the chain ID. It's going to take the bid amount, the bid details right here. And the bid details is this encoded detail function of everything that we broke down. You see there's a lot of redundancy on here to make sure everything is correct. And then the collateral basis points are set to the max. Collateral is how much you're willing to put on your collateral, how many points fees, you got to pay that for the max. So those are the fees that are happening on the OEV network that you're willing to pay in order to do this. So there's I think a 5% fee for that. So whatever is left over goes back to the DApp. So we're
okay. So
maxing on that.
confirming it's basis points. It's not like a hard number, right? So
No.
yeah.
Currently, this version is maxed to certain. There's no specific hard number. It's whatever you're willing to bid on that network. So it's a part of the bid value. So if I did 1 ETH and there was 5%, it would be like 0.05.
Yeah. I'm
Yeah,
just
yeah,
asking to clarify because if I was doing this, I need to like remember I'm putting it
yeah,
in basis point units because that's
yeah,
like
yeah. But
it's like
we
what
for right now, it's
100th of a percent? Is that what it is?
yeah, yeah,
Okay.
yeah. And then the expiration time. How long is this bid good for, right? You I don't know why you would have it for a super, super long time or more than a day when you're doing liquidations. Bids change all the time. People change their health factor. Oh, I'm gonna, get liquidated. I better pay back my loan or add more collateral. So you can do short amount of time, but basically this is how you do it. This one is set for 12 hours. So you just change this to an hour or 60 minutes or however you want to change it. And then basically this is going to console log out that we've done our bid in the transaction house. Right. So now we're going to compute our bid ID. Once we do a bid, how do we actually know what our bid is? Right. So we have to get what our bid ID is, and that's how we're going to be able to check it. Basically, there's encoding, right? So we have the Ketchak or Kekak, 256, and we're basically popping in our address, bytes 32 and bytes 32, which is our OEV network wallet address. So this is the wallet of the signer doing the bid, right? Which is basically our EOA. The bid topic, which is the encoded details of everything that we just popped in here, all our details, proxy address, bid conditions, everything that we did a bid on. And then we're getting the bid details, which was basically this bit details that were the encoded function on here as well. So that way we have all the details on here. So between that, we are able to generate our bid ID. So that way we know in the auction house to see if we won or not, right? And so amazingly, we did win this transaction because we set it up that it's a fair price that like whatever the next one is going to win. But we set up listeners, right? So we have this promise that is basically waiting to see if our bid is awarded. So however you want to do your listeners, this is how we do it in JavaScript on here. We're listening to the filter to make sure that our awarded bid has our bid ID, right? So if our bid ID wins, the auction house will send out an event. If we win, we're like, okay, the bid has been awarded. Now we know that we can actually set up, update the price feed on mainnet, right? So we just listen to see if we win. I haven't put a listener to see if we lost, but you could do it like, hey, I didn't win this bid, somebody else did. Then this is a very simple OEV auction here. So now we
Is
just
this
have this thing.
the type of person you are? Really?
I'm a winner. W's only. W's only. Max bid. But you'll see that once we get that winning thing, this awarded transaction is what has the winning signature, right? So if I win that bid, the OEV auction is basically saying, okay, you won the bid based on the details of all this, of who's going to update and who's going to be able to do what oracle, what chain. This awarded transaction has all that information on that signature. So with this signature that has all the details saying you won and this is who can update and when you can update, we're going to bring that back on called perform OEV update with all the signature details on here. So let's break down the perform OEV update. And that is here where we have our signature that we won. And we're going to make sure that we are on the right chain, which is the default scroll mainnet. We're going to make sure that our bid amount is the same that we were willing to bid on the OEV network. So we got to pay this out on mainnet. And then we're actually going to build our OEV searcher multi-call. We're going to call this object out. This is the object for our multi-call. And then we're going to go ahead and make sure that we are set up for scroll network on here. So we're just basically building this up for a scroll network for our multi-call. Say, hey, this is our object. And then we're going to call the update transaction. So we're going to external multi-call transaction with value because we're paying out the value. And this is where a lot of the magic happens. And this is why you need to understand multi-calls is we are bulking the transactions all here. So for right now, you'll see that each one is an array. This is the target. This is the address that we want to update, right? So the proxy address, we're using the chain ID that we set right here, right? So we're doing this on scroll network on here with all the API 3 addresses. So we're paying the API 3 server here. The awarded transaction is the signature that we won that has all the details. What is the proxy address that we need to pay? How much value we need to pay? Who's going to do the update, right? That's all here in this transaction. And then this is how much did we bid that we were going to pay? We need to let them know how much value that we actually bid out. So we're letting that transaction know. And then this is how we're sending the actual value through the bid amount right here. If this is a multi-call, if we were doing our transactions, obviously this is just doing the update of the OEV. We would then also be doing our liquidation, right? And so here there'd be another array of information where we have the address of the borrow lending DApp, right? So that'd be the smart contract address of the borrow lending DApp. And then here, well, let me just close that. I know it looks horrible. Here again, we would also have something in the array here that would say, comma, and then another array here. And bulk in this is all the bytes detail of the liquidation. So then there, okay, here's how we did the liquidation. We're paying back this, we're receiving this back in there. And then we don't need a bid amount because we're not paying back anything unless we're sending ETH in there. And we don't have to value transfer because we're paying it like in tokens. So let me clean this up. But this is how you would use the multi-call of being able to bulk all your transactions in a single call. Let me clean this up so it actually like compiles. 1 second. But does that make sense?
Yes.
Okay, cool. So here we're just doing a update. We're just updating the Oracle. But again, when you're doing the multi-call, this is the sauce, the secret sauce. You can bulk all these transactions. This is how like account abstraction contracts work. When you approve and swap all in the same transaction, it all basically gets sequentially done in an array for each one of these, depending on what your things that you need. So here again, just to reiterate, we're just updating the Oracle and we are paying out our bid. And so we send that transaction, we just wait for it, and we get the notification that our Oracle update has performed, right? And then we just return the update transaction. And then the next step, right, is we actually have to report back to the OEV network saying, hey, we behaved, we did what we said we were going to do. We're going to report the fulfillment update. And so we're going to, call this function again and basically set up our object for the OEV network again, talk to the auction house, right? So we basically, provider, mnemonic, signer, that whole spiel. Again, we're using our chain ID code and we are basically encoding our bid details and setting it to bid detail hash on here because we were just encoding it again. And then telling the auction house, hey, we're reporting our fulfillment. This is our bid topic. This is our hash. And this is the transaction hash that we did it with. And it's going to say, all right, up Oracle reported update. And then it's going to say, all right, did the auction house get the confirmation? And it's just going to listen for it. Say, okay, you've been confirmed. Cool. Our bid is now safe. It will not get slashed, and we're done. And we've completed the whole transaction. So again, all this script, piece by piece, all comes down to, oops, scroll here, order transaction, bid. There we go. That was too much code. Comes down to simple things. We place our bid, right? What are our terms? What are our liquidation prices that we've calculated? We win. We perform the update on the chain that we're doing it on, for this case, scroll, and then we report that we did it. What we do with this, performance is totally up to us. That we do in the multi-call, right? Whatever we want to do. Do we want to perform the update, perform a flash loan, pay back the loan, do a swap on a DEX, cash out? That all goes in this perform OEV update on our multi-call as we bulk it out on there. So let's see it live. Once you have all your assets, and really all you have to do to do this in real time is update the actual proxy address, chain ID, how much you want to bid, and what are your terms. That's pretty much it. But let's see it in action. So yarn, submit, bid, update. Let's make it big. Let's make it large. And you kind of see the flow of how everything goes. So there we go. My bid has been placed, waiting for the bid to be awarded. So now I'm listening to see if the auction goes through. We won. Yay. And so now that the bid has been awarded, I'm going to send my transaction on scroll. Oracle update has been performed. It's been reported. And so now I'm waiting for that confirmation of fulfillment from the auction house. And then we eventually will get that. And then I should have looked at the price beforehand, but I'm pretty sure it's going to get updated to the latest one. But let me just scroll here. Oh, there we go. Let me refresh this, and it should be a little bit more accurate. And there we go.
No, it
2459.
went down.
Yeah. So the big question is, how do you know what price it's going to be? And there's different dashboards tools we use. This is what we use internally here. This is the ETH/USD for scroll. We check every minute on the API 3 server. So you see like the sign data that's here, that's available, what's actually being shown on here. So like there's a difference in price. Even if, as I did the last update, there's a market trend, right? We're also
Right.
checking other oracles too. Security again is our major factor here. So like if we're off and other oracles are on, something's off, right? So we get warnings and everything to make sure that everything is on the up and up. So you can always check what the real data is that we're reading from different oracles versus what's on chain. You can see the deviation. So as a searcher, you want to know where the trend's going, what's the real value you're going to get. Obviously, the script was way faster than following the playground of click, 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 right? Because everything happens all within seconds, right? So
Mm,
like the script is the way to go because you can't click on there. But what's to stop somebody from creating a hackathon project where you can actually liquidate on a borrow lending app, right? So you can open the game up for people to just click, oh, would you like to liquidate this position? How much are you willing to bet or bid to update this oracle to liquidate? The world is like kind of like open with this like newfound kind of technology of
yeah.
where you can kind of take it now. Because now that you don't have to wait for it to hit the threshold, if the price is what it is now, you can just make it all happen now if you're willing to bid for that price.
Mm. Now I'm wondering, like, Billy, how many bags are you holding from
Well,
OEV? But that's not something we discuss. We're learning here about
yeah.
coding, not about yeah, because
Yeah,
I'm like, wow, this is actually very, very easy and unscary and like
yeah,
all the things that I think tend to be blockers. And I'm like,
yeah. Yeah, the one of the hardest thing for like DeFi is it's hard to get good information personally. So like as I'm doing this and building it out piece by piece, I want to make it where people can understand it and like understand the why, not just like, oh, here's how you do it, but why
yeah.
things happen and like how the flow is. Because when you look at this code, you're like, oh man, that's a lot of information. But when you break it down piece by each like function of what you're doing with the liquidation, it's like, okay, this makes more sense, of how I go it.
Mhm.
Here's the bread and butter on the multi-call. This is why I use multi-call. So again, like I said, even if you say I hate DeFi, I hate this, using multi-call has more features for other use cases in the space. So if the only thing that you got out of here was multi-call, awesome, right? You still got it still. So it's not like just
Yeah.
pushing API 3 stuff. It's like all kinds of skills that you need in order to get there. Plus, like how are you going to run your own like backend, right? How do you keep those
Mhm.
liquidations? That's kind of like my segue into like the DeFi. I'm going to sneak peek it in here, but this is the borrow lending dApp on here that has a lot of information on here. And so instead of like importing ABIs and whatnot, like I'm actually doing all the ABIs piece by piece. So you can
Mm.
see each function that gets called on there. So like, okay, on this contract, I call this, on this contract, I call this. Why do we use adapters? How do we use adapters? All that kind of stuff on here is all going to be done. And like they're all scripts ready to go. Like when we
Oh.
mimic a liquidation, when we mimic like how does it work, borrow lending works, all that on there. And kudos to the API 3 team. Like they really killed it on this. Like the next session we have, I know it's kind of a sneak peek, is like deploying a full-on Aave fork on here, ready to go with a front end complete. So you can make your own tokens. I didn't make Billy Jitsu token, but we can mimic that. But you basically learn how it all works. You have your supply,
Yeah.
your borrows, and then it probably like session 3 will probably be split into 2 parts of like understanding how and why this works. And then
Mhm.
the second part will actually be doing the liquidation of like now that we have leverage and you realize the loan to value and the rewards, how to actually do the liquidations, how to pay back the tokens, how to receive the asset that you want in a sense. It's a lot of stuff to like break down. So yeah, I'm looking forward on there. I just kind of figure I'll sneak peek it on there.
Oh,
So you can get
I guess, like, one last question because we never actually defined what is the Oracle Fastlane?
Oh, well, instead of waiting for the Oracle to update on the threshold, like instead of waiting for that ETH 2020 to happen, you're fast laning it to the current price of what it is right now.
Okay, cool.
Yeah. So
That's
you
what
can
I
take
was
advantage.
thinking, but I was
Yeah.
like, I don't know if that's the catchphrase,
Yeah.
Billy was trying to
Yeah.
get at. Okay.
Well, yeah. I mean, the whole point of like, and people were like, why does Oracle's pay me, right? Like, as a DApp, you have the choice of like so many different oracles, and at the end of the day they all do price feeds and they're all pretty solid, right? I'm happy to say, and I'm going to knock on wood a million times here, is that we've never had a misreport. API 3 since inception has never had a misreport on any data. Like they take this super seriously on there. But
Mm.
most people are good. I'm going to say that they all give you numbers on chain, but we're the only ones that pay you. So
Okay, okay,
yeah,
good to
yeah,
know.
yeah,
The wheels are turning.
yeah, yeah.
Um But yeah, super cool. I am very excited for, I guess, session 3 because I guess for the level uppers out there, our third challenge is going to be coming out soon, which is actually writing your own Aave contract. Um, but I guess Billy can make it give you all the answers and
Yeah.
incorporate it front end, and it'll be way, um, yeah.
It's extremely complicated, and actually, if you do browse the API 3 ecosystem, GitHub, I made a very basic borrow lending dApp to help you understand how it works, because when you look at repos, like for DeFi especially, you have make an ERC20 token, cool. And then here's Aave with like 30 different contracts and like all these things that you have to like absorb. And there's nothing in between. There's nothing in there. So I made a simple borrow lending dApp that kind of shows you what happens when you borrow, when you stake, and when you borrow it, your loan to value, and how the
Mhm.
liquidations work. It's a much more digestible version of it. Again, there's no pool management, there's no Oracle control. It's all made with API 3 oracles, so it's pretty straightforward. It's not very upgradable, but it gives
Yeah.
you the general idea of how it works. Like when I put something in and then we put something out, how it works like a bank.
Mhm.
That's much more consumable than like reading a whole for production smart contract that has three different engines running three different things on the background, right? So
Yeah.
yeah, there's a lot of stuff on there. If you scroll through the ecosystem, you see a lot of stuff that I do to break down, and there's a lot of tutorials on there. So yeah,
Yeah.
it's about education, right? Like at the end of the day, API 3 is cool and I like it, but I like learning a lot of different things too. You'll see me explore a lot of different ideas and playing around with a lot of different apps because I'm curious. I love the space. So, hey,
Yeah,
yeah.
yeah, no, as Billy is amazing. Thank you so much for joining us today. I guess we need to schedule session 3.
Yep.
So I guess keep an eye out. All of our updates are on Twitter at Level Up Web 3. I think Billy had a QR code
Oh
earlier.
yeah, yeah, yeah. Check
If
that
you
out
want
there.
to
Check
check
the link.
out all of the stuff that he's doing.
Play with
Um,
OEV. I'm giving it some time so you can actually play with it, guys. So like
yeah, yeah,
mess
yeah.
around with it. I know it costs real money, but like if you are playing with it and show us that you are playing with it, we can sponsor like a few bucks on the OEV network. No big deal. Like, yeah, mess around with it, do all that.
Well,
So
I'm just
yeah.
waiting till flash loan section so I don't have to touch any of my own
I
things.
already have a repo up there in the flash zones for
Ah,
Aave
yeah.
V2 and V3. Like if you look for tutorials, there's only Aave V3, which is a much simpler version than Aave V2. I
Mhm.
have both. So you can play with it. That's already in the ecosystem page as well. So that's been created. And I think I have a video breakdown too. So on there of like how to borrow and then a simple DEX. So then you can swap your tokens on there. So it has like a custom made DEX on there. So
Yeah,
yeah,
yeah.
mess
Okay,
around with it or DM me for the link.
perfect.
Yeah.
Thank
It's already
you.
done. It's been done.
I know, but it's like I wanna wait until someone, like, tells it to me in person, so
Oh, yeah, yeah. Yeah, no worries, no
yeah,
worries. Yeah,
yeah, yeah.
we're slowly building you up to, like, okay, understanding oracles, understanding how to update oracles, understanding how to liquidate, and then all putting it all together with a flash loan and a big old liquidation and then profit, right? That's the end of the day. Yeah.
Oh, we have a "Hey, Billy, when UFC watch party."
When I'm actually home. I've been traveling so much. I'll be traveling again, so that's why we haven't set our date yet. So yeah, it will happen soon. I'll be traveling to Europe for a hackathon, and then I'll be back, and then DevCon happens, and then so like we'll figure it out. We'll figure it
Yeah,
out.
yeah,
Yeah,
it'll happen.
yeah.
Okay, cool. Again, thank you so much, Billy. This is really awesome. I'm very excited for the next session. I learned so much, namely because I also was not super familiar with, like, MEV, so this was, um, really helpful. But, okay. Well, I guess have